then for our next function, we have x of t equals t times e raised to at times the u of t ordinary step function. We have the condition of u of t is equal to 1. So we have the Laplace transform of t times e raised to at u of t times or equals the Laplace transform of t times e raised to at times e raised to negative s dt. Simplifying our improper integral, combining like terms, we have by the loss of exponent, we have t e raised to negative s minus a dt. And since we have two terms, by the integration technique, we can use integration by parts, and again, we will apply the DI method or the tabular method. Having this form, we have d and I, we have t as in the derivative section, and e raised to negative s minus a times t in the integral section with respect to t. So evaluating our t, we have the derivative of t is 1 and the derivative of I constant is 0, and the integral of this is negative 1 over s minus a 1 times negative s minus a times t, and having again its integral, we have both negative, so we have 1 over s minus a. There's another neutralizing factor in here, having it as squared here, times e raised to negative s minus a times t. And applying the tabular method, we can match derivative and integral terms by this. So anything we multiply in here is 0. So we can observe that in our past examples, in which variables are engaged in terms, so our last term will not be 0. So we concluded that if we have a term like this, we can stop having the derivatives when we get to 0, unlike to our past examples in which variables are engaged, so it is infinitely, or it has an infinite number of derivatives and integrals, unlike in this example. So we will stop when the derivative gets to 0. And multiplying this term, we have t times e raised to negative s minus a times t over s minus a. Don't forget our sign, positive, negative, positive. So it had, since multiplying this, we have a negative minus e raised to negative s minus a times t over s minus a squared, having the limits of 0 to positive infinity. And evaluating this form, we have 0 minus 0 and minus 0 minus 1 over s minus a squared. That's it. And cancel it. 0. Distributing our sign, we have the Laplace transform of t times e raised to at u of t is equal to 1 over s minus a squared. So that is the Laplace transform of our function t times e raised to at u of t.